You've heard about streaming integration, the need for stream processing, and often hear the term streaming SQL. But what is streaming SQL and why is it so essential to real-world, real-time solutions? IBM created the structured query language, or SQL, in the 1970s as a declarative mechanism for working with relational data. It's been used for 4 decades as a way of creating, modifying, and querying data in almost every database on the planet. However, because databases store data before it is available for querying, this data is invariably old. In the world of real-time data and streaming systems, there's also a need to work with data, and Striim chose 5 years ago to use a variant of SQL for stream processing. This streaming SQL looks very much like the static database variant, but needs new constructs to deal with the differences between stored and real-time continuous data. Database SQL works against an existing set of data and produces a result set. If the data changes, the SQL needs to be run again. Streaming SQL receives a continuous and never-ending amount of data and continuously produces new results as new data arrives. The simplest things that can be done with this data are filtering and transformation. These operations work event by event, with every input potentially creating 0 or 1 output. For example, if we want to limit data moving from one stream to another by a field like location, we could write a simple where clause. If we want to combine first and last names into full name, we can use concatenation, with other more complex functions of course available. However, because streaming queries receive events one by one, additional constructs are required for aggregate queries that work against a set of data, so windows and event tables need to be introduced. A window contains a set of events bounded by some criteria. This could be the last 5 minutes worth of data, the last 100 events, or whole events until no more arrive within a certain time. Windows can also be partitioned, so the sets are based on the criteria per some data value. For example, the last 100 actions carried out per customer. Event tables hold the last event that occurred for some key. For example, the last temperature reading per room. Streaming SQL can work against windows and event tables and will output results whenever there is any change. Aggregate queries against windows will recalculate whenever the window is updated, giving running counts, sums over microbatches, or activity within a session. For example, to create a running count and sum of purchases per item in the last hour from a stream of orders, you'd use a window and the familiar group by clause. Enriching data is just as easy. It uses the standard notion of a join. The Striim platform supports all types of joins familiar to database users, including inner, outer, cross, and self joins through nested queries. Striim enables users to load large amounts of data into memory, in caches and event tables, from databases, files, HDFS, and other sources. This can be reference, context, or historical data and can be updated through the incorporation of CDC. For example, if we want to enrich the order stream to include details about customer and location, we can join with reference data loaded into caches from the customer table and the locations database. Of course, this just scratches the surface of what can be achieved through streaming SQL. Production queries can be much more complex, utilizing case statements and even pattern matching syntax. Try out Striim today and discover the power of streaming SQL for yourself.